up at the sky on any given day, and clouds are almost always there. They regulate the planet's temperature. They carry fresh water from the ocean to the land. They reflect sunlight back into space and trap heat from the surface. Without clouds, Earth would be either a frozen rock or a boiling desert. But there was a time when Earth had no clouds at all. The story of how clouds appeared on this planet is the story of how Earth built the atmosphere, the water cycle, and the climate system that every living thing alive today depends on. When Earth first formed approximately 4.5 billion years ago, the surface was entirely molten. Temperatures at the surface exceeded 2,700 degrees Fahrenheit in the immediate aftermath of formation. At those temperatures, water cannot exist in liquid form and cannot exist as vapor in the lower atmosphere. It would be instantly vaporized and driven into the upper atmosphere or lost to space by the intense solar radiation of the young sun. The early atmosphere was dominated by volcanic outgassing. Hydrogen, carbon dioxide, nitrogen, sulfur dioxide, and water vapor being released continuously from the molten interior as the planet cooled. There was no oxygen. The sky was not blue. It was likely a thick, hazy orange or yellowish brown, colored by the dense mixture of volcanic gases and the different wavelengths of light scattered by an atmosphere with no oxygen and no ozone layer. In this early phase, clouds as we know them, water droplets or ice crystals suspended in the atmosphere, could not form. The surface was too hot, the atmosphere too chaotic, and liquid water too scarce at the surface level to allow the condensation that produces clouds. As the surface of the Earth cooled over hundreds of millions of years, the conditions for cloud formation began to develop. Clouds form when water vapor in the atmosphere cools sufficiently to condense around tiny particles, dust, volcanic ash, sea salt, or other aerosols, forming droplets or ice crystals that remain suspended in the air. Two things are required: water vapor and a mechanism to cool it enough to condense. Both were being supplied by volcanic activity. Every volcanic eruption released enormous quantities of water vapor directly into the atmosphere alongside carbon dioxide, sulfur dioxide, and other gases. As the surface cooled below approximately 112 degrees Fahrenheit, the boiling point of water, water vapor in the lower atmosphere could begin to condense rather than simply evaporating back into gas. The first clouds on Earth almost certainly formed from this volcanic water vapor as the surface cooled sufficiently to allow condensation. Scientists estimate this may have occurred as early as 4.4 billion years ago, supported by evidence from ancient zircon crystals in Western Australia that indicate liquid water existed at the surface at this time. Liquid water at the surface requires a water cycle, and a water cycle requires clouds that were forming and raining and evaporating continuously from very early in Earth's history. Interesting puzzles in Earth science known as the fate-young sun paradox. The young sun was approximately 70% as bright as it is today. Simple calculations suggest that with a sun that dim, early Earth should have been completely frozen, yet the geological and chemical evidence clearly shows liquid water existed at the surface as far back as 4.4 billion years ago. The most widely accepted explanation involves elevated greenhouse gas concentrations, particularly carbon dioxide and methane, trapping enough heat to compensate for the dimmer sun. But clouds also played a role in this balance. High-altitude clouds reflect sunlight back into space, a cooling effect. Low-altitude clouds trap heat radiating from the surface, a warming effect. the balance between these two effects determines whether clouds warm or cool the planet overall. On early Earth, with a dimmer sun and a different atmospheric composition, the balance between cloud warming and cloud cooling was different from today and is still an active area of scientific research. What is clear is that whatever combination of greenhouse gases and cloud cover existed on early Earth, it was sufficient to maintain liquid water at the surface, and liquid water meant a water cycle, which meant clouds were forming and raining and evaporating continuously from very early in Earth's history. As Earth's atmosphere changed over billions of years, so did its clouds. The Great Oxidation Event, approximately 2.4 billion years ago, covered in Episode 7, fundamentally transformed the atmosphere by introducing free oxygen for the first time. Oxygen in the upper atmosphere reacted with ultraviolet radiation to form ozone, creating the ozone layer that filters harmful UV radiation from the sun. The presence of oxygen and ozone changed the scattering of light in the atmosphere. Oxygen molecules scatter blue wavelengths of sunlight more than other wavelengths, the same reason the modern sky appears blue. Before the Great Oxidation Event, with little or no oxygen in the atmosphere, the sky was a different color entirely, likely a pale orange or yellowish hue, similar to the skies of planets like early Mars. As oxygen accumulated and the sky turned blue, clouds against that blue sky became the white formations visible today, their appearance shaped by the same light-scattering processes that colored the sky behind them. By approximately 2 billion years ago, Earth's atmosphere and cloud systems were becoming increasingly similar to the modern world, still evolving but recognizably part of the same planetary climate system that exists today. The first clouds formed on a planet with no oxygen, no blue sky, and no life. They were dark, dense, and volcanic, nothing like the white clouds drifting across the sky today. But they were doing the same thing clouds have always done, moving water from one place to another, regulating the planet's temperature, and making the surface of Earth the kind of place where something remarkable could eventually happen. Every raindrop that has ever fallen on this planet fell from a cloud, and clouds have been falling rain on Earth for nearly as long as Earth has existed. This is cosmic Earth.